Good afternoon. I'm Anand Buddhdev from the RIPE NCC. First of all, thank you for welcoming me to Novi Sad and giving me this opportunity to present about Ansible. Sorry, that's just the dyslexic brain in me. So this is perhaps a little bit different from some of the other topics you've been hearing about. I would like to first of all know from you guys, just raise your hands, how many of you are familiar with things like CF Engine, Puppet, Chef, or SaltStack? Okay, so there's a few people here who are familiar and a few not. So I'm going to be talking about Ansible, which is well, first of all, let's see what an Ansible is. Those of you who are fans of science fiction and have been watching Star Trek or Ender's Game may have heard of this thing called an Ansible. It's a fictional device that can supposedly communicate over great distances in instantaneous time. So it doesn't matter, it bends, it breaks all the laws of physics, it doesn't care about the speed of light or any of that stuff. You talk on one end and you can hear the other person on the other end no matter how far away they are. And that's what an Ansible is. So if you haven't already heard about an Ansible, then when you go back home, download a copy of Ender's Game, legally of course, or buy the book and read the book, and you will come across this word in this book or this movie. But more interestingly for this talk, Ansible is a system and automation tool. It helps system administrators to perform all kinds of tasks on their systems. You can run individual commands on your systems with Ansible. You can configure them completely, and you can also use it to maintain the state of a system. So if you think about configuration management systems like CF Engine or Puppet or SaltStack or Chef, what they do is they read some kind of recipe or manifest or policy file that is configured by a system administrator, and then they execute this state on a server, and they maintain this state. So if a service should be running, then they keep it running. If a file in the repository has changed, then they know how to restart the necessary service that depends upon it and stuff like that. So Ansible is similar to them, but of course it is different in some ways, and we'll see that in a bit. So first of all, some bits about Ansible. It's written in a programming language called Python. Are you all familiar with Python? Okay. It's a very nice and easy to use language. It's also easy to learn. You can very quickly write code in Python. It's great for prototyping stuff, but it's also a nice language for rapid system administration tasks or little things that you might want to do. This makes Ansible itself quite easy to read. I mean, if you try and read C code, it's quite convoluted. You have to understand all the basics of C programming and stuff, but with Python, lots of things are more intuitive because it's a higher level programming language. And if you're already familiar with Python programming, then it gives you the opportunity to extend Ansible in your own way without having to delve into C code and stuff like that. Ansible is open source. All the source code is available on GitHub, so you can go away and clone the repository, fork it, make your own features, send pull requests, all that stuff. This is in contrast to something like CF Engine, which doesn't make its repository available to people. And even if it did, who wants to delve into C code? Ansible is very, very easy to install and run. You can literally get started in just a few minutes. In fact, if you're online now on your laptop, by the time I'm finished with this presentation, you can have Ansible up and running and configuring your systems It's that easy and that quick. And it can scale from just a few systems, like 5 or 10, all the way up to hundreds or thousands of systems. So it's highly scalable. So what do you need to run Ansible? Well, as I mentioned, it's written in Python, so you obviously need a Python interpreter on your laptop. Most modern Linux distributions ship with Python these days, fairly recent version. You need at least Python 2.6. If you have an Apple laptop, then that will also have a recent version of Python on it. So you can use that. For Windows, again, you can quite quickly fetch the latest Python and install it. And then Ansible needs a few Python modules to run. One of these is called Jinja 2, which is a templating engine. Markup Safe, which is a dependency of Jinja 2. PyYAML, which is a Python module to read and parse YAML files. And YAML is yet another markup language. It's a very simple markup language for storing, variables, dictionaries, lists, things like that. And there's a couple of optional modules. One is called Paramiko, which is an implementation of SSH in Python, and PyCrypto, which is required by Paramiko to do all the SSH crypto stuff. However, you don't need to use Paramiko and PyCrypto. You can also use OpenSSH with Ansible, and OpenSSH is again installed by default on all Linux and Mac OS systems these days. And it is actually much more flexible to use OpenSSH. So how do you install Ansible? Well, if you're ready to try this out, then go ahead as I speak. On any operating system, you can create a Python virtual env. A virtual env, for those who don't know, is a self-contained installation of Python where you can install all your modules and dependencies, and it can be independent of your system Python installation, so it doesn't touch the base system. It essentially makes a copy of all the Python libraries and links them into a separate directory. And once you've installed this virtual env, then you use pip, which is the Python package manager, and you just type pip install Ansible. It'll go away and fetch the dependencies, and you'll be ready to go in less than 5 minutes. If you're on a distribution such as CentOS or Fedora, then Ansible is also available in the repositories, so you can enable the EPEL repository, and then just type yum install Ansible and you're done. Ansible consists of a few programs that you run, and these are Ansible itself, Ansible Doc, which provides documentation, Ansible Galaxy, which is an auxiliary tool to install additional components from the Ansible repos, Ansible Playbook, which is what most people tend to use, and we'll come to all of these in a bit, and Ansible Pull, which I will also mention briefly. And then the bulk of the work is performed by these things called modules. And modules are, in the base Ansible installation, they're all written in Python. And these modules are designed to perform specific functions on a system. So there are modules to copy files, there are modules to stop, start, restart services. There are modules to install packages, to manage cron tabs, sysctl settings, add and remove users and groups, and so on and so forth. So there's something like 50 or 60 modules available in Ansible at the moment, and these 50 or 60 modules together are quite sufficient for performing most system administration tasks. And if you find that there isn't a module available for something that you want to do, you can easily create one of your own. In any language, it can be Python, which is recommended, but you can also write it in Perl, Ruby, you can write a bash script to do it, as long as it follows the Ansible API for communicating with modules. One other important aspect of Ansible is this thing called the inventory. Basically, this is a file where you list all the hosts that you want to manage. If the host is not in the inventory, Ansible will not manage it. So this is a good place to list all the systems you want to manage. The inventory is flexible. It allows you to group various hosts together, by function or location, for example. If you want to be even more flexible, the inventory can be a directory instead of a file, and then you can just drop files into this directory, and Ansible will concatenate all these files and create the inventory out of that. And for those who want to be even more flexible, the inventory can be an executable script that will spit out your host names on standard output, and Ansible can use this to work with an inventory. And this allows you to be flexible. For example, you could store all your host names in, I don't know, a MySQL table or LDAP or whatever you fancy, or all these key value stores like Redis and what have you. So here's an example inventory, and the default location on standard Ansible systems is etc Ansible hosts, and you'll see in there that I've listed 4 hosts: AWS 1, 2, 3, and 4. These happen to be Amazon virtual machines, and then beneath them you see names in square brackets, and these are group names. So I've got 3 groups here: DNS servers, web servers, and mail servers. And I've listed some of my hosts inside these group names. So Ansible knows that it has to manage 4 machines, AWS 1 up to 4, and there are 3 groups. It doesn't matter if a host appears twice. Ansible just canonicalizes them into a single host name. But if this host name appears under a group name, then that host is also added to that group. So you don't have to worry about listing hosts multiple times. So how do you actually run Ansible? Now that we've seen what the components are, let's start with the most basic of Ansible modules. Ansible comes with a module called ping, and all it does is a ping, but not an ICMP one. It does an Ansible ping, and the way it does that is by making a connection to this host over SSH and checking that it can execute a module on that host, and if the module can be successfully executed, then it returns a PONG. So you run the command Ansible, you specify which host you want to run this command on, you give it the module you want to execute and any module parameters. Now the ping module doesn't actually take any parameters because all you're doing is checking if the host is up. So if I type Ansible all -m ping, I'm saying to Ansible, run the ping module against all the hosts in my inventory. And if I run this against my example inventory, then it will ping these 4 boxes, AWS 1, 2, 3, 4. If it connects successfully to all 4 of them, then you see that it will return PONG for each one of them. And this is an interesting parameter here changed. The value is false. And because the ping module doesn't actually modify anything on the target system, there's nothing changed. So Ansible is telling you that it actually didn't change anything anywhere. All it did was successfully connect it to the host. So this is the most basic module. And most of the time you won't actually use it, but it's useful to test connectivity to all your servers. Now let's do something more useful. Suppose I want to run a command, who am I? And I want to run it against the host AWS 1. Then I type Ansible AWS 1, I address one server, I provide the module name, which is the command module, and I give it the parameter who am I. So I'm saying to Ansible, use the command module to execute who am I on this target host. And Ansible will make an SSH connection to this host. It will transfer a copy of the command module. It will then execute the command module with the parameter who am I. This command will be run and the results will be returned to you. So here we can see that Ansible says this command was successful. RC equals 0, that's the return code. And the actual output of the command, who am I? EC2-user. I want you to focus on something I said a few seconds ago. Ansible copies the command module from your laptop onto the target system, then executes it, returns you the result, and deletes the module. This means on that target system AWS1, I don't need to actually install anything. As long as I can make an SSH connection to this host, Ansible has everything on your laptop to manage this system. All the target system needs is Python. That's amazing. Your target system does not need anything besides Python. Now, if you compare it to CF Engine or Puppet, you actually have to install agents on these target systems, and the agents have their own dependencies, and some of them can be quite bloated. With Ansible, you don't need anything. So it's very lightweight, and it's easy to get started. So here now you can see the power of Ansible. Let's run a slightly more complex command. I want to address all my web servers, and I want to do a long listing of the etc password file. So I say to Ansible, run this command on all my web servers. So let's go back to the inventory for a second. So under web servers, I have 3 hosts. And I'm saying to Ansible, run the command ls-l etc password. You'll notice that there's no module parameter here. That's because in Ansible, the command module is the default module to run if you don't specify anything else. So I can take a little shortcut and omit the -m parameter. And the -o parameter says print the results out on a single line. And if I now run this, Ansible comes back with 3 lines. It has connected to each of the 3 hosts. It connected successfully. There were no errors running this command. And the output of that ls-l command is printed on my screen. So I'm running it against 3 hosts. I could run it against 30 hosts. I could run it against 300 hosts. Ansible will connect to all of them in succession, run the commands, and present all the results to you in a nice, easy to read format. Any questions so far? Yes? Gentlemen?
Yeah, does the Python version on client matters?
Yes, it does matter. You need at least Python version 2.6.
No, I meant in comparison to the machine you are working from.
No, that does not matter. If on your laptop you happen to have Python 2.7, but the target machine has Python 2.6, that's okay. It just needs to be at least Python 2.6. Okay, so let's continue. Now here's an even more interesting example. I want to install a package called Screen, and I want to install it on all my servers. So I call Ansible, I give it the target name all. The module is yum, so I'm going to manage CentOS boxes here. The parameter I'm passing it is name equals screen. So I'm saying to Ansible, I want you to install a package called Screen. -s means run this command under sudo on the target system, and -o again for one-line output. Now you need sudo because yum needs to run as root. Otherwise, when you connect as yourself and you try to yum install a package, it will fail. So Ansible will now connect to all these systems, will transfer the yum module. It will then use sudo to invoke the yum module and call yum to install Screen. And something very interesting for you to notice here. Notice the third server, AWS4. It has a changed value of false, whereas the other three have a change value of true. What Ansible is actually telling you here is that on 3 machines, AWS 1, 2, and 3, it actually made a change. In other words, it installed this package, but on AWS 4, it did not change anything. What you infer from this is that the package screen was already installed on this server. So Ansible had to do nothing. Before Ansible actually runs any command, it checks to see if it actually needs to do anything. If nothing needs doing, then it doesn't do anything. Yes?
I have one question. When you type this command,
Yes.
do you need to type the passwords for every server every time? Or
So when you type this command, that's a good question. Ansible will prompt you for a password. The assumption here is that you have the same password on all these boxes. If you have different passwords for every different box, then this one command is not going to cut it, because it only gives you one opportunity to type the password, and then it uses this password for all the servers.
Can you build some modules to take passwords from some list?
You can do it one by one.
Yes, you could address the servers or the groups of servers one by one. That's possible, of course, so that you can use different passwords for all of them. Generally, of course, most people will be using the same password everywhere. Having different passwords for every server you manage is a little bit esoteric, I think. But this is a limitation.
Yeah, what about the keys?
Sorry.
SSH key, can it be
Certificate.
Yes, of course, you can use an SSH key. Then you no, sorry. The SSH key is used for connecting to the server as yourself, as your user account, but you will still need the pseudo password to become root. If you want to use SSH keys directly with the root account, you can do that. If you feel that is a better mode of operation, if you don't want the 2 steps, then you can connect directly as the user root with a key, and then you don't need sudo.
But deciding on the case, or only root or only non-root? I mean, if I use sudo to switch, I mean the SSH connection could be made with a root key, right?
Well, if you connect as the user root.
Sure, but probably for some of the modules I don't want to connect as root.
Yes, so I will show you some examples of how you can do some more tailoring and customization in the later part of this presentation. This is actually a very simple use of Ansible so far. So we're using it in a way that most people don't actually use it. This is for doing ad hoc stuff. So if you want to do more complex stuff, we'll come to that in just a short while.
Just one more.
Yes?
Do you have some kind of indication of failure? Because change false is, that means that nothing has been done.
Yes.
But what about the indication that you tried to do something and then failed?
Yes, if that happens, then do you see the key called results?
Mm-hmm.
In there you will have more, the error message that was spat out by Yum will be in that field there.
Okay.
Yeah, and of course if the SSH connection itself fails, then Ansible will also tell you that it failed to connect to a certain host. So you'll also see that. Okay, I'm just going to quickly run through these examples now because I'm mindful of the time. So here's some examples. I want to install a package called NSD on my DNS servers. So again, I do Ansible DNS servers, module yum, parameter name equals NSD, nice and easy. Now, of course, I've installed this package called NSD and I want to provide a configuration file for it. So I now call Ansible again. This time I'm going to use the copy module to copy a file called nsd.conf from my laptop to the destination directory etc ncd nsd.conf onto these DNS servers. And finally, having copied a config file, I want to actually start NSD, this name server daemon. So I'm going to connect again to all these servers, Ansible DNS servers. I'm going to invoke the service module. and give it the parameter name NSD, and the state started. So the service module is quite intelligent. It will first probe the system and figure out whether it's traditional system 5 style etc init.d scripts, or whether it is an upstart system or system D, or what do they use on there's a couple more that it knows about. So it'll figure out what kind of init system you're using and then call the appropriate commands to start the service. So, it takes away it abstracts away a lot of the system detail from you. Now, this was a pain. I had to run the Ansible command 3 times separately. First to install a package, then to copy a file, and then to start the service. Wouldn't it be nice if I could combine all these steps into some kind of recipe and then tell Ansible to go and execute them one after the other? That's where the power of Ansible comes. Ansible provides a feature called playbooks, and these are recipes of what to do and on which hosts, and these can be quite complex and arbitrary. You format this playbook in YAML. That's why you needed the PyYAML module. YAML is very easy to read and write. You can set variables in your playbooks. So you can provide parameters that could be different for different hosts. And playbooks can also define handlers. So handlers are actions that need to be taken if a certain state changes. So if you, for example, copy a new config file, then you want to restart some service. And these are reusable. So if you happen to write a nice complex playbook for yourself, you can give it to your colleague and then he can reuse the playbook to execute the exact same steps. And you both know that you're doing the same thing. You're not doing different things on the system. So here's a simple playbook. Let's say this file is called httpd.yaml.yml. And in here, I first tell it which hosts I want to run against, web servers. I want to use sudo for this task. And then the tasks that I want to run on this system are first install httpd. I'm using the yum module. You'll notice I'm saying state latest. So this will even check to see if Apache needs to be upgraded. You might have an outdated package. Then I'm going to copy a config file, and I'm using this notify parameter here to tell Ansible that if it happens to copy this file across, and the file that was on your laptop was different from the target, then it also needs to restart httpd at the end of this play run. And then here I'm saying make sure that httpd is enabled and running. And then here's a handler to restart the Apache service. So Ansible will run this playbook and make sure Apache is running and restart it if the config file had changed. Now here's an example of executing this playbook. And now I don't call Ansible, but I call Ansible playbook, a different command, and I just give it the playbook name. And because I asked Ansible to use sudo in the playbook, it's going to prompt me for a password, and then it's going to connect to all the hosts. You'll notice it says at the top they're gathering facts. Ansible has this other feature where it will probe the system and determine various parameters of the system, like the kernel version running, the OS family, the interfaces, IP addresses, all this stuff, because you can use this information in your playbooks. And then you notice that it's actually executing the tasks. So the first one to install the package, you'll notice on AWS 1 it said OK, which means nothing changed. The package was already there. And on AWS 3 and 4 it changed the state, so it either installed or updated Apache. Then it copied the config file. So the config file on all 3 was outdated, so it copied all of the files. And then it restarted HTTPD there. And at the bottom, it presented a nice little summary to see what it did on which hosts. Ansible has a feature called idempotence or idempotence, which means that if you run the same playbook again and nothing needed to be changed, then it will do nothing on the system. So here, if I rerun this same playbook a few minutes later, you'll see that everything comes back okay, 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 okay. Nothing needed changing, change 0, failed 0, unreachable 0, everything's fine, hunky-dory. And if you felt so inclined, you could run this every 10 minutes to make sure your web servers were up and running. A little bit overkill, but there you are. You can do it. Now suppose you have this whole inventory with several hosts, but you want to run a playbook against just a single host for some reason. You don't want to connect to like 200 hosts in your inventory. Then you can use the -L lowercase l option, which stands for limit. And here I'm saying run this HTTPD playbook, but only against this one host. Because I know that I only want to make changes on this one host. Maybe you're doing something like rolling updates. Your first update in one server and then you're going to do the other server and stuff like that. Another powerful feature of Ansible is templates. Ansible uses the Jinja templating engine. Jinja is also quite widely used by web developers. So it's a templating engine, which means it reads a text file, and anything that is surrounded by placeholders is replaced by values. That's what templates normally do. You can do variable substitution in them. Jinja also provides you some nice control structures, if, then, for loops, and it provides filters for transforming text from one form into the other. And earlier we saw that when Ansible ran, it gathered facts on the system, and Ansible makes these facts available to the Jinja templating engine. So you can use them in your templates. You can also embed variables inside playbooks. So for example, here, I want to set a value called NSD procs, the number of NSD processes, to 8. And I'm providing a list here. This is a YAML list. I'm giving it 2 zones. And then I'm giving it a template to parse and stick that into the directory etc NSD. And this is what my template looks like. So most of it is just plain text, and the Jinja templating engine will not touch anything in this playbook. But here you notice a tag, a brace, followed by a %, and that tells Jinja that it's actually got to do something here, do some substitutions. So here it's going to run a loop, and it's going to basically do a for loop, and it's going to insert 5 lines IP-address with values 0, 1, 2, 3, 4. And so my config file will have those 5 lines in them. Up here you notice 2 opening braces and 2 closing braces. This value is read from the playbook where I defined it earlier. So this server count is set to 8. And then I have another for loop here for zone in zones. So that's where my zones are, 2 zones. And this for loop is going to run through both of them. And I'm going to create these zone stanzas which are NSD specific, and put some parameters there. And this template will be nicely formatted into an NSD config file. And if I later want to change something, I just change it here in the playbook, rerun it, NSD will be reconfigured, and all is hunky-dory. Moving along, Ansible provides you something called roles. Roles are a way to group functions together and group their tasks, handlers, variables, and other things into a simpler directory structure. So here, for example, I've created a role called my role. Very, very creative there. And this role has files, handlers, tasks, templates, and vars. And this allows me to group things together. So for example, if I create a role called NSD, then I can keep the NSD templates, config files under this role. So it allows for some nice, good directory structures. You don't have to lump everything together in one big giant directory. And then you can use roles in playbooks. So for example, here I'm saying in this playbook, on all the hosts that I'm managing, please apply the roles users and NTP, because they happen to be common to all these boxes. Then on the host mail service, apply the role exim and dovecot, because I want to run exim and dovecot on them. Please don't shoot me for that. I happen to like exim. And then on the DNS service, I want to apply the role NSD and TCP dumper. So NSD to run the service, and then I want to do TCP dump so I can see the queries coming in. And so far we've looked at Ansible running from your laptop against all your managed boxes. And this feature of Ansible is called push mode. Now this is what Ansible is mainly designed for. Okay, Ansible is designed to be lightweight, and not heavy like CF Engine and Puppet and all that. So you don't need any agents, and every time you want to change state on your systems, you connect from your laptop and you make changes. So you're pushing changes out to your boxes. This is very lightweight. It works well for small numbers of hosts. So if you have, 10 boxes that you manage, or 20 or 30, it'll work fairly well. You can instantly write new playbooks and run them. You can, give them to your colleague to run. But the problem with this push mode is that if you have large numbers of servers, it will not scale well. If you have, say, 1,000 servers that you're going to manage, then Ansible will spend a considerable amount of time connecting to all of them over SSH and executing all the tasks and things. It doesn't really scale unless you set up a farm of management workstations. But, people don't do that. And of course, if you want to maintain state on your system, so for example, if you want to make sure that if Apache has died for some reason, you want to restart it with Ansible instead of with something like upstart or systemd, then you need to run Ansible in push mode frequently. Like I said earlier, you could run it every 10 minutes to make sure your web server was running, but then you'd be sitting up there all day and all night. You'd have a job, but it would be a boring job. And as you add more and more hosts to your inventory, your playbook runs will take longer and longer to run. Because, Ansible cannot connect to all your hosts altogether. I mean, if you try and connect to 1,000 servers from your laptop and spawn 1,000 SSH connections, your poor laptop might die. So Ansible, of course, limits itself by limiting the number of simultaneous hosts it connects to. The default, I think, is 20. So if you have 30 hosts, then it will connect to 20 of your hosts first and start running tasks. And as soon as one host reports tasks complete, it will open another connection to another host. So it limits resources on your laptop, but that means the more hosts you have, the longer it will take. So Ansible can also run in this local mode, and this is what we at the RIPE MCC use it for. In local mode, Ansible becomes a little bit like CF Engine, Puppet, Chef, and other stuff. Because what you do is, instead of connecting to each host, you install a copy of Ansible on the target system. So it is now no longer as lightweight as the push mode. You do need to install Ansible on the target. And then you can use some favorite system you like to check out your playbooks onto the target. Ansible pull itself can be used for this. It can check out playbooks using Git, Subversion, and a few other things. Or we just use rsync. So the target machine dials home to a configuration box, rsyncs all the playbooks, and then executes them. And you then run Ansible with the -C local option, where you're telling Ansible not to actually make an SSH connection because you're already on the target machine. You just want it to execute tasks. And this scales much better. You can have large numbers of hosts, and they're all dialing home, fetching their playbooks at random times, updating, so it scales much better. And even if this host is disconnected from the mothership, Ansible will keep running periodically at a period you define, and it'll maintain state at least. So if a service that should be running has died, then it will start it and stuff like that. So this box can continue unattended. So at the RIPE NCC, we have our entire Ansible setup inside a Git repo. What we've done, and this is a little bit different, is we've created a pure Python Ansible distribution inside our Git repo. And this runs from our users' laptops, but the same distribution is rsynced out to our target machines. So they have the same version of Ansible with all the modules. And it runs exactly the same on target machines. And we use two playbooks inside it. We have a playbook called Bootstrap, which we use just once against a newly installed host. So if I have a new server, I install, I kickstart it or something, and it'll come up in a basic state with a pre-installed SSH key. And the bootstrap file or YAML will go and do an initial setup of this box. And then we have a playbook called main, and this is where we define all our various functions. Oh, so I've just explained this. Bootstrap does the bare minimum configuration. What the Bootstrap does is installs all the packages required for Ansible to run. Then it installs a shell script to rsync our Ansible. We are currently using CentOS, so CentOS 6. So we run Ansible under Upstart. And Upstart is a supervisor, so it runs the Ansible playbook. And then there's a sleep 10 in there, sleep 600, sorry, so it sleeps for 10 minutes. And then the script dies, and so Upstart says, oh, program exited, restart it, nice and easy. And it runs Ansible every 10 minutes. This is nice because I don't have to check for a previous copy of Ansible, so I don't need locks and all that. And because this script will run when the machine was booted, the machines calling home will do so at a staggered interval. If I run it on the cron job, then precisely every 10 minutes, all these machines in a thundering herd will, hit our configuration server, which runs rsync, and bring it to its knees. Whereas doing it this way allows a staggered approach. And then once we've run this bootstrap file, it updates the repo with a couple of SSH keys, and the operator can do a git push, and this goes out. Our distribution server checks out this git repo every 5 minutes and provides restricted rsync to the target machines, so they can do nothing but check out the Ansible playbooks and the Ansible distribution. And then on the manage host, we run Ansible playbook locally. We give it its own host name to run against, so it doesn't try to connect back to all the other its brothers and sisters in the cluster. Everything is logged into varlog Ansible, and this playbook will run even if the rsync has failed, and it will keep on maintaining state. So finally, future improvements. At the moment, we sync our entire repo out to all the target boxes. So for example, our DNS servers also have our mail server configuration. Our mail servers also have our web server configuration. It's not really a problem. I mean, if somebody gets onto the web servers, then they'll be able to see the mail server configuration as well. But it's not that big a problem, and if we want to, we can improve it by limiting parts of our Git repo to different target systems, so they only get certain config files. And at the moment, we don't have any active feedback from the playbook runs. So if for some reason this playbook is failing continuously, then I won't know about it unless I log into the server and check. Ansible provides something called callbacks, which I'm currently investigating. And these callbacks can send some kind of message home to say, oh, this playbook run failed because you had a syntax error. The syntax errors are bad because the entire playbook run will fail. Ansible will just fail to parse the YAML file, and it all hell breaks loose. I mean, as an operator, I would have checked my syntax before pushing it into the Git repo, but sometimes people do stupid things. But at the moment, I don't have any feedback, but I could. And there are callbacks for this. So that was the end of my presentation. I tried to keep it to time, so I don't, I think I'm in time, yes. But thank you for listening, and if you have any questions, fire away. Gentleman right at the back.
Currently, Ansible Galaxy doesn't know about dependencies. It doesn't get them, right? Is there any effort to make Ansible Galaxy actually get all dependencies of the role?
Okay, that's a good question to which I don't know the answer because I don't use Galaxy myself. For those who are wondering what Ansible Galaxy is, it's a collection of roles, which I mentioned earlier, that people write themselves and contribute. So it's kind of user contributed code, and so it may not be the same level or quality as the core distribution. But in order to answer his question, I'm not sure about the dependencies because I don't use Galaxy myself. I'm sorry. There was another question. Yes.
Do you have any feedback maybe how it integrates with Docker, for example, or how it integrates with some continuous integration tools like Jenkins or can be?
Yeah. So Docker is used to create these little virtual machines into which you package all your applications and stuff. And frequently, what you have to do is, once you've brought up this virtual machine, you need to run things on it, repeated tasks. And that's where Ansible is very good. You can have this playbook that you write, which is essentially a list of steps that you need to execute. About integrating it automatically, I haven't done this myself, and I don't know enough about Docker, but perhaps you have some kind of post VM creation scripts that could be run, and perhaps you can hook Ansible into that in some way. If anyone here is using Docker, maybe they can answer this question.
Actually, there is a Docker module in Ansible, so you can use it from Ansible directly.
Excellent. Okay. I wasn't aware that added a module, a Docker module. Yes, back there.
How come you decided to use Ansible? Because from your configuration in local mode, I think the Puppet is that much better.
Okay. So here's our little story. We began with CF Engine at the RIPE NCC, and we still have CF Engine on several boxes. I personally hate CF Engine with a vengeance. Sometimes it locks up on a target system, with no explanation. It fails in weird and strange ways. CF Engine doesn't actually provide you the functionality of the modules that you have in Ansible, for example. So if you want to install a package with Yum, you have to actually write all this functionality into CF Engine yourself. And people have contributed code for it, but it doesn't have this same elegance that Ansible provides. And CF Engine policies are notoriously hard to read and to write. I mean, we've had colleagues who started and it took them, poor guys, 3 months to understand how our CF Engine policies were all organized. And then we gave them an Ansible playbook and said, here's a playbook that configures these servers. And they stared at it for about 2 minutes and said, yeah, that makes sense. I can extend this. So I wanted to get rid of CF Engine. Yes, Puppet has been around. Lots of people use it and stuff like that. But I also find Puppet rather heavyweight. And what I like about Ansible, which I'm not sure if you can do this in Puppet, but certainly in Ansible, I can change one of my playbooks on my laptop. I can run it against a target server in push mode. And if I'm happy with it, I can commit the changes into the Git repo and do a Git push, and the same change will then be applied to all our servers. So I can use the push mode to test and then rely upon pull mode to take over on all the other systems in our cluster. And I love this sort of two-way setup that we have. I don't know if you can do that in Puppet. If you can, yeah, I suppose it could be. But one of the other reasons we don't like Puppet is because Puppet's own definition language for writing tasks and recipes or what have you, in itself takes a while to learn. Whereas with Ansible, in 2 minutes somebody can be started because everything's formatted as YAML, so there's not much learning to do, and the modules abstract away a lot of this functionality in a nice and easy way. I mean, if you're using Puppet, by all means keep using it, but think about Ansible, a different way of doing things. Yes?
Did you consider the source stack to use instead of Ansible?
That's a good one. We were sort of aware of SaltStack when we were looking at Ansible. SaltStack is sort of similar to Chef and Puppet and all that, in that you have the minions and the master and state maintenance and all that. But it was a little, let's say, premature at the time. SaltStack. It's changing very rapidly. And what we didn't want to do was spend hours and hours reading documentation about SaltStack. We just wanted to get started with something, and that's what Ansible gave us. So we we thought about it, but we decided we didn't want to go there because of the extra learning curve involved.
I cannot, because I use Puppet.
Yes.
And I don't like it at all. And I use Ansible now.
Yes.
And also using the source tech. Source tech has one big advantage over Ansible.
Yes.
Because it does not use SSH.
Yes, of course.
And when the server is under heavy load,
Yes.
you cannot connect to the SSH, but you can still do with source tech. You can kill some process and log on to the server.
Yes, that's true. You have a sort of out-of-band method that does not rely on SSH. That's true. Yeah. I guess that's an advantage over SSH. Yes.
Actually, I have quite some experience with SaltStack, and I have to admit that it looks a lot more like Ansible than all the other frameworks do so far.
Yes.
But there's one thing about SaltStack that makes it, at least in my situations, quite often useful, is that it's the clients that actually phone back to the server.
Yes.
And they keep a line open.
Yes.
Which makes it a lot more usable in situations where your clients or your targets are either behind a firewall.
Yes.
Or have a dynamic IP address and you don't have DNS for that.
Sure.
The thing is, does Ansible have a similar solution to, let's say, combine the local mode and the push mode in that way that you get a similar situation as with SaltStack?
Yeah, so Ansible doesn't have this functionality built in, but this is quite easy to do because from your target machines you can create a backward tunnel to your management workstation. So yesterday in Vesna's presentation, if anyone was here, that's what the right Atlas probes do, for example.
Okay.
They dial home with SSH and they keep this connection open, and we can talk to them by sending commands to the port forwarding port that they've set up.
So you still have the central console then?
Yes.
But
Yeah, so
okay.
we're not using this with Ansible at the moment. Our Ansible setup connects over SSH and then uses rsync to check out the playbooks and then disconnects and runs them. But if we wanted to, then this can easily be done with a persistent SSH dial back connection.
Yeah, because with the local mode you generally don't have the central control anymore. That's
Yes,
only for configuration but not for action.
exactly. Yes.
Okay, thank you.
I'm still around, so if anyone wants to actually see our setup, look at some of our playbooks, I'm happy to show them. There's no secrets in there, so come see me. Thank you.
Thank you.